We previously talked about the basics of Wi-Fi networking. Now let's put that information to use and see how to use the WICED SDK to connect our development kit to Wi-Fi. Every WICED Wi-Fi chip has a section of flash called the Device Configuration Table, or DCT. This table holds lots of information about the device, including Wi-Fi information, such as the SSID, channel, security type, etc. To pre-configure the Wi-Fi section of the DCT for your project, you need a file called Wi-Fi config dct.h. You can get a template for that file from the SDK under Include Default Wi-Fi config dct.h. You should copy this file into your project's directory and rename it to just Wi-Fi config dct.h. The default Wi-Fi config dct.h looks like this. There are 3 sections to this file. The first contains information used if you want your device to act as an access point during configuration. That is to say, you want it to be an AP during the initial device setup so that you can connect to it from a different device to configure the Wi-Fi settings. The second section contains information for when your device will be an AP during normal operation. In fact, it's possible to use WICED devices as both an access point and a station at the same time. The third section contains information needed if your device is going to be a station that connects to an access point. For the majority of this class, we will be using only the third section. To include your DCT information when the firmware is built, you must add the following line into the makefile. That is, Wi-Fi config dct.h equals the name of your Wi-Fi configuration file. From the default DCT file, you can right-click on the definitions and select Open Declaration to see all of the available choices. For example, here are all the types of security that WICED currently supports. The DCT information is mapped into the flash by the SDK. You normally don't need to know about this since you can set up everything in the WICED config dct.h file. However, if you want to read or write the DCT on the fly, for example, to change access point settings during configuration, you will need to know some of these details. The DCT is divided into sections. The section called Wi-Fi config contains all of the Wi-Fi networking information. If we right-click on Wi-Fi config, we can see all of the different values available. The second entry, Stored AP List, is an array of available access points that the device is pre-configured to know about. The first element in that array is the default AP that the device will automatically connect to. If we right-click again, we see that each AP has details, a key length, and a key. Right-clicking on the details show where the AP's SSID and other information is stored. The manual explains how to read and write various sections of the DCT. We won't cover that in detail here in this video, but feel free to read about it on your own. Once the settings are in the DCT, it is very simple to connect to the network. We use a single function called WICED Network Up. This is where you need to stand up and applaud. I think that WICED Network Up is a remarkable thing because in one simple API call, you're connected to the network. It has to figure out tons of stuff, radios and security and encryption and get connected and ones and zeros turning into radio waves. This is the result of an unbelievable amount of research and development. There is a massive amount of things that need to go right for you to be reliably connected to the network, and WICED takes care of those things automatically for you. All right, back to the code. WICED Network Up, that function takes 3 arguments. First is the type of interface. In our case, This will be WICED STA interface, since we want to connect as a station. Second is a method to specify the IP settings, such as the IP address, the gateway address, and the net mask. In our case, we'll use one of those daemons I told you about earlier, the DHCP daemon. So we will use WICED use external DHCP so that it will automatically connect to a DHCP server and get you an address. The final argument is not needed in this case, since we are not specifying the IP settings of our device. Remember, we're letting the DHCP server do it. So you can just set that argument to null. However, if you want to use a static IP address, this is where you would define those settings. Note that many of the WICED functions return a value of WICED result type. This can be very useful for debugging purposes. It's often a good idea to capture this value and print it out to the debug UART. The WICED result data type is a giant nested enumeration that specifies what happened during the function call. If you right-click and open declaration, you can see the different possible return value buckets. If we select the top-level generic bucket, you will see that a return value of 0 means WICED success. Earlier, I mentioned that the WICED device can act as an access point during the initial setup so that you can connect to it and specify the Wi-Fi settings like SSID, security type, etc. for the AP that you want your IoT device to connect to. This is one of the ways that an IoT device can be introduced to your network. Other methods include using Bluetooth to configure the Wi-Fi settings, connecting via USB, or hard coding the AP settings. For the rest of these videos, we will use hard-coded settings for this class, but there are other examples of other types of configuration inside of the SDK directory. At this point, we know everything we need to know to attach to an AP from our WICED development kit. Now let's make a project. The project is called 05, since remember, this is chapter 5, 01 attached WPA2. In the make file, we need to specify the name of the Wi-Fi configuration file. The configuration file tells the firmware to connect to an AP called WW101 WPA2 with WPA2 PSK encryption and the passphrase as shown. When you run the solution project, you will have to modify these to match the actual network that you're wanting to attach to. In the C file, we just called network up. Remember, network up after the WICED init, and then look at the result. If the result is equal to WICED success, then we turn on an LED. That means we were successfully connected to the network. If the connection did not work, then we blink the LED to indicate something went wrong. I typoed the SSID, or I gave the wrong password, or something like that. Now let's program the project and see what happens. The LED turned on, so that means we're connected to the Wi-Fi network. You can also open a terminal window and then reset the kit to see the debug information that is printed by default when the device boots and connects to the network. Now, let's expand that project a little bit to print out some additional information about the network. First, we will copy the 01 attached WPA2 to a new project called 03 WPA2 info and make all of the necessary changes in that project. In the C file, we will add in function calls to get and then print the IP address that was assigned to our device, the net mask, the gateway IP address, and the IP address of Cypress.com, and finally, our own MAC address. Once the changes are made, we just program the project into the kit and look at the output on the terminal window for the new information. That's all there is to connecting to a Wi-Fi network and getting information about it using WICED. In the solution projects, we provide an example project that shows you how to read and write the Wi-Fi configuration in the DCT. Please feel free to explore that as well. You can find it on our website. Now that we are connected to the network, we want to start sending and receiving data. That will be the topic of the next chapter. As always, you can post your comments and questions in our Wi-Fi developers community, or you're welcome to email me at alan_hawes@cypress.com or tweet me at AskIoTExpert. Thank you.